In earlier discussions, we examined complexity, change, and opacity, and we've started to look at how they interact with dependency visibility. Each affects project performance. Today we look at another one, decision latency. Decision latency is the time between recognizing the need to act and acting. That delay converts uncertainty into financial exposure. In my experience, decision latency is when complexity slows understanding, change shrinks decision windows, or opacity slows recognition. Complex conditions may delay decision making because the organization cannot yet agree on what reality is. When reality is unclear, organizations either delay decisions or commit prematurely and make those commitments irreversible. Change, on the other hand, does not just require new decisions, it can invalidate decisions that are still being formed. And opacity slows recognition. When the need for action is not visible, or if it's impossible to see how to decide in the context, then either the resulting decision may be wrong or delayed. In major capital projects, timing determines whether risk is contained early or it compounds into a crisis. Sovacool, Gilbert and Nugent found that delaying complex nuclear projects for 2 years added as much as 15% to the cost of the electricity it produces. So not only was the project itself more expensive, but so was the cost of its product, borne by the consumer. An early imperfect decision can often be corrected. A late decision, even a correct one, is usually expensive. Decision latency is not usually caused by hesitation without reason or incompetence. It comes from how projects are structured. Decisions follow a common pathway: signal, interpretation, authority, and action. Information moves upwards and authority moves downwards, and the project waits in the middle. This creates risk. If governance and decision-making is not timely, procurement windows close, dependencies evolve with multiplying potentials, construction sequencing needs time to advance, and the result, commercial exposure, grows. That's a problem when there is high uncertainty and multiple party involvement, which is typical of mega projects. Here's an interesting quote from the Strategic Investment Board's Brett Hannum. Staff who lack confidence in their own expertise seek the widest possible external confirmation of the judgment that they are asked to make in an approach described as defensive decision-making. In real life, that's company hierarchy and information sharing at work, and the intent isn't bad. It becomes a problem when it's put ahead of project-level pragmatism, and as such, decision timelines or structures cannot cater for the project situation. Escalation pathways outlast decision windows. A manageable reversible issue can quickly become irreversible simply because response timing was slow, and a paradox can then occur. Waiting creates the illusion of more options because more information appears. In reality, the ability to act is shrinking and option value is being destroyed. Decision latency increases when those who see problems cannot authorize action. In project delivery, those who are at the detail level of the project, where dependencies interact, expertise is deployed, and challenges seen, aren't always those empowered to decide. This can be engineers seeing design conflicts, site teams observing productivity breakdowns, or supply chain teams identifying looming shortages. If they're not empowered to decide, that automatically creates a distance between identification of an issue and the decision to resolve it. That distance is an escalation pathway, and the more of them you have, the longer the decision latency. Every escalation layer adds the time between seeing a problem and solving it. This gap between awareness and executable decision is a source of performance deterioration. Once more to Brett Hannum. Even when staff have good intentions, it's hard to get anything done with so much complexity and so many management layers to work through. When staff do not share the same intentions, process provides limitless opportunities for obstruction. Complex projects require cross-functional agreement, and that's normal, but alignment has a timing cost that is rarely engineered deliberately. When and how often do the right people meet to get agreement? That doesn't mean reducing collaboration. In decision-making on mega projects edited by Kenneth Button, it's argued that the exclusion of key players in a project delivery creates risk, and instead, process design, that is, the way the project is run, requires the social complexity of many players, many different interests, to be acknowledged and catered for. That means balancing multiple viewpoints with the practicalities of getting them all in the same room. When coordination cycles outlast decision windows, exposure can increase. The problem isn't collaboration, it's if it arrives after the moment of effective intervention. Alignment is valuable until timing makes it dangerous. From my experience, this is a driver of delayed decisions. Traditional project management frameworks do not create adequate communication structure between experts and decision makers. Misapplied delivery frameworks can increase decision latency by creating communication patterns that do not match project decision or risk conditions. Under uncertainty, organizations increase decision latency in the name of control. More reviews, more reporting cycles, higher approval thresholds. Additional oversight can increase perceived control while reducing response speed. Control is not the volume of oversight, it is the ability to intervene while options still exist. In one large financial services transformation, decision rights sat outside the delivery system. A deterministic project management and governance framework became the shell in which all activity needed to live, and an agile one used in a minor part of the software delivery. This caused decision latency due to misaligned governance. Deterministic project management frameworks are ineffective in high uncertainty exploratory projects, and of limited use in technology initiatives where plasticity, i.e. what you can change, remains relatively high throughout. Additionally, where agile frameworks intentionally accommodate change, that accommodation is only as good as the reporting and governance structure that executives and decision makers have been placed into. Minor decisions needed to exit the project management frameworks and go through the ordinances of the client company, which meant waiting days or weeks before resolution. Major decisions required C-suite assent, which meant waiting for them to convene and assess. In financial services, regulation is tight, which means care must be taken with impactful decisions. But when project management structure doesn't cater for that all the project context, you get delay and waste. The project in question exceeded a year overdue. As that anecdote describes, projects can experience persistent delay because governance design is misaligned with delivery reality. Decision forums meet less frequently than risk conditions change. Authority thresholds prevent timely local action, decision criteria are ambiguous, and escalation routes are congested. These are not behavioral problems, these are system design issues, and system design determines decision speed. Governance architecture is therefore determinant of project delivery speed. Decision latency can convert uncertainty into irreversible capital exposure. Labour accumulates and risks idling, contract claim likelihoods increase, resequencing reduces productivity, procurement choices narrow, and capital burn continues while momentum stalls. In simple terms, you're paying for the team to wait, and you're paying for every day that your project isn't finished and earning money by itself. However, this should not be treated recklessly. There's nuance to what makes good decisions timely. Forcing irreversible decisions for the sake of timeliness, especially when uncertainty persists, is not a universally good idea. My analysis draws a sharp distinction between delays during execution and delays before physical commitments are made. While delaying a decision during construction is catastrophic, real options theory suggests that delaying a final investment decision, or an FID, during the front-end planning phase can actually increase project value by allowing unpredictable regulatory or market uncertainties to resolve before capital is irreversibly locked in. The difference is critical. Delaying commitment before physical execution preserves flexibility. Delaying decisions during execution destroys flexibility. Understanding this distinction separates strategic patience from operational paralysis. The takeaway then is reversibility, which becomes increasingly difficult as the project progresses. Engineering reversibility into decision-making, especially early in projects, can preserve decision-making timeliness without disproportionately increasing risk. So what do high-performing projects do differently? High-performing projects engineer decision speed alongside reversibility as deliberately as they engineer technical outcomes. They shorten escalation pathways, they delegate authority where risk tolerance allows, they increase decision cadence during volatile phases, and they expose constraints early through transparent reporting. These measures do not reduce governance discipline. They align governance speed with delivery reality. One project I worked with was looking at upgrading safety equipment on an industrial site. An option included a replacement technology, and the cost per unit was around 5 times that of the existing technology. In the exploratory early phase of the project, we had to reverse our position on the use of technology twice. First, because the company decided it was too expensive. But around 3 days later, we put forward numbers on the scope of the technology. While it was 5 times more expensive per unit, each unit could replace 100 of the existing solution. Suddenly, it was 20 times more cost effective, and our team setup and relationship with the decision maker meant that decisions could be made rapidly. We then learned of the requirement to test the technology with the harsh environmental conditions on the site, especially during winter. And working back from that, we needed to order them within the next week to accommodate for lead times and import. In this case, we engineered reversibility into the choice of ordering them by ordering a sample to test. So while it was a capital commitment, it was much smaller than the commitment to go all in. In this example, maximum reversibility was preserved at all stages of decision making, which resulted in the project being insulated from changing requirements and information. Decision latency is not primarily a cultural issue. It is shaped by how governance systems are structured. In the next discussion, we examine how governance design itself influences capital project performance, and why many governance models unintentionally increase risk rather than reduce it. If decision speed determines risk exposure, then governance design becomes a capital allocation decision.